Good morning. Today we're looking at scientific notation. So some of you may have seen this in a science class already. If so, awesome. If not, that's okay. We're going to go through it again and then we'll see it later on in our textbook as well. So scientific notation is great for instances like these where we are multiplying big numbers. Okay, so let's look at number 1. We have 1,000 times 1,000 times 1,000. All right, so we have 1, 2, 3, 4, 5, 6, and then 9 zeros. So that's a lot of zeros. There we go. We have 1 billion. Okay, and now we have 0.1 times 0.1 times 0.1. So this is going to be a smaller number, where we have the 1, 2, 3, 4, 5 zeros in front of that one. And now number 3 is a little mixed up. They're all 4s, but they're all different types of 4s. We have a tiny 4, and then a bigger 4, and then a small 4, and then a much bigger 4 number. Okay, so we're going to multiply those out and get 25,600. Okay, so if you don't know how to do that, that's okay, because this is just an introduction to what scientific notation is. So scientific notation is when we express a number as a product, and I'm going to highlight this word for a moment, as a product of a number between 1 and 10 and a power in 10. So let's think about what this would look like. Okay, a product means I'm going to see a multiplication sign. So I'm going to go ahead and write my multiplication sign. And then what is a number between 1 and 10? I'm going to use 6 as this example. And a power of 10. So I should have a 10 here and then a power of it. And I'll just say 10 squared. Okay, so one of the most important characteristics of scientific notation is this part right here. Okay, this number needs to be less than 10, greater than 1, and less than 10. Okay, so here's a number that we're going to try to express in scientific notation. One of the reasons why we use this notation is to express really large or really small numbers, especially when we have a tiny calculator that can only hold so many zeros. This comes in really handy. Okay, so our first rule was that it had to be a number between 1 and 10. So 9 is a number between 1 and 10. So we would put a decimal point right here, and that's going to give us this 9.3. But I need to know which power of 10 am I using. So I know you guys are familiar with moving decimal points around. So we're just going to see how many times we had to move that decimal point in order to make this smaller number of 9.3. Okay, so we're just going to count 1, 2, 3, 4, 5, 6, 7. So we're going to multiply that 9.3 times 10 to the 7th power. Okay, let's look at another one. Okay, now we have this really tiny number. Before I do that, I just want to remind you how we looked at negative exponents on Wednesday, I think it was. But I'm going to do right here 2 to the negative 2nd power. So you guys remember that negative exponent means it's in the wrong place. So I'm going to rewrite that with 1 on top. And this is 2 squared on the bottom. And I'm going to simplify this. Okay, 2 squared is 4, 1 over 4. Does anyone know what this is in terms of decimal? 1/4. So that's like a quarter. 1/4 is a quarter, so that's 0.25. So notice how this number with a negative exponent made it a small number expressed as a decimal. Okay, so I want you to keep that in mind. So with scientific notation, going back to this, we need to express this with a beginning number that's between 1 and 4. So is 45 between, 1 and 10. Is 45 between 1 and 10? That's not going to work. So we're going to make it 4.5. This is where we want our decimal point to be. So how many times do we have to move this decimal to get to the 4.5? 1, 2, 3, 4, 5. Okay, so we are going to be multiplying this by a power of 10. However, that power is going to be negative, just like the one up here. It is negative, and that is what's going to give us that decimal. It's a tiny number. All right, here's some examples. Okay, write the following numbers in scientific notation. So I see my starting numbers. I have 1, 6, and 7. Is 167 between 1 and 10? Nope, can't use that. How about 16.7? Nope. So we're going to stick with 1.67. So we need to figure out how many times are we moving this decimal point to get the right number. 1, 2, 3, 4, 5, 6. That's where it's going to land. So that's 1.67 times 10 to the 6th power. Okay, let's look at this one. Okay, we have our numbers 5 and 9. Is 59 a number between 1 and 10? Nope, not in this world. So we're going to put a decimal point right here so that way we have a number that's between 1 and 10. That's 5.9. So how many times do we have to move our decimal point to get to the to express the number correctly? 1, 2, 3, 4. Okay, so this is going to be 5.9 times 10, and then is it to the 4th power, like that? If I left it like that, then it would be a big number, right? But it's a small number, it's a small decimal, so we're going to make sure that our exponent is negative. All right, so here's a chance for you guys to practice, and you can pause here to let students answer. You're just filling in for this part right here. How many times did you have to move to the left or to the right? So for number 1, we have 3.9. We have to move it 1, 2, 3, 4. So that's 4 times. And for number 2, we have to move it 1, 2, 3, 4. But it's a small number, so that is a -4 exponent. Okay, here's another one. What is the missing factor? So that's our beginning number. Is it going to be 725? Nope. How about 72.5? That's not between 1 and 10 either. So this is 7.25. We're going to have the decimal point land right here. Okay, and this one isn't too bad. We already have a 9. I mean, that's the only number there. So another way that you can do this is by, it's not really cheating, but it's using your resources, right? They already told you how many times you have to move your decimal point. So we can just move it 1, 2, 3, 4, 5. We see that our number is just 9. All right, so this one doesn't really give you any hints. You have to try this one on your own. And I'll give you a minute, or no, I'm not going to give you a minute. You're going to have to pause this to get a minute so you guys can work this out on your boards. But I need to continue, so this will actually upload with good amount of time. So this is a small number. We have that negative exponent, and then how many jumps? 1, 2, 3, 4, 5, 6. This is good. And then we want our decimal point for number 6 to be right here. Then we can count how many jumps. 1, 2, 3, 4, 5, 6, 7, 8. That's a big number, so there's a positive exponent there. Okay, so now that we know how to make things in scientific notation, do you think you can reverse that? Can you put numbers in scientific notation back in standard form? How do you know how many times to move the decimal point to the left or right? Okay, is this going to be a big number or a small number? It's going to be a big number. That means we need to move our decimal point to the right 5 times. This does not mean that you have 5 zeros. It means you are moving your decimal point to the right. So I'm going to move it 1, 2. I don't really have any space to write it anymore, but I moved it to the right twice, which means after that I just have zeros, right? So I should have 3 zeros. And then over here, we have that negative exponent, which means it's a small number, which means I need to move my decimal point to the left. So I'm going to move it to the left. I don't really have any room. So it has 2 zeros in front of it. I'm going to try to draw over this. 1, 2. So this is 0, 0. There we go. So we should have 2 zeros in front of that 8, 4. Okay, so here you have another chance to try this out on your own with your boards and see if they're right. So you can pause here and then I'll go over the answers. Okay, for number 1, we are going to the right 3 times. So this is 1, after that will be zeros. So we have 2 zeros after the 4 and the 9. Number 2, I have that negative exponent, which means I'm going to the left. So that's 1, 2. So I should have 1 0 before the 3 and right after that decimal point. Positive exponent means I'm going to the right. And since the decimal point technically is like right here, it looks like this one will be 6 zeros. And there's your 6 zeros. So here's some examples of why scientific notation exists. So one of the reasons why they call it scientific notation is because it's used mostly in sciences when they deal with tiny little things like organisms or whatever, and also large things like the speed of light. Okay, so how can we express the speed of light in scientific notation? What's my first factor going to be? Is it going to be 186? Nope, not between 1 and 10. How about 18.6? Definitely not that either. So we're going to put our decimal point right here. And then how many tens did we use? This is 1, 2, 3, 4, 5. And it's a big number, so it is a positive 5. So 10 to the 5th power. Okay, we have now nanometers. A nanometer, thankfully they tell us that a nanometer is 1 billionth of a meter. 1 billionth. So if you think about that and how many zeros it would have, okay, it would have quite a bit. But anyway, they want us to express that in meters. And I don't know if you remember the other example where we had something billion and how many zeros it was, but I'm going to go ahead and write, let's see, 3, 6, 0, 0. Ooh, I feel like this is wrong. Give me 1 second. I feel like I should start backwards. Okay. So, you know what? Let's just do a different number. We're going to do 5 billion, just to show you how many zeros there are, in case you don't know that. But I'm sure some of you do. Okay. Yeah, I definitely should have started backwards. Okay, so here we have, hundreds, thousands, millions, and this is your billions place. So how many zeros are we looking at there? That's 9 zeros. And since it is a small number, it is a negative 9. Negative 9. Okay. So that's it for today. You can go ahead and do your classwork. Hopefully you won't have any homework today, and I hope you guys have a wonderful Friday.